Hmm?
Eigenvalue, eigenvector.
Eigenvalues in all of those, yeah. Logistic regression also you've covered. Okay. Linear regression. Linear regression also you've covered. How about data cleaning? Hmm? Hypothesis testing. Central limit theorem. Okay. Stats module. Okay. You haven't done the data cleaning like the outliers and missing values. None of those things you've done. Okay. Okay. So we'll begin there. But before we get started, so what module is this one? Is everyone in the right class? What are we going to study here? Machine learning, right? So what is a machine learning? Mhm. Okay. Anybody else? Any point of view?
Learns from data.
Hmm?
Machine learns from data.
Machine learns from the data, right? Yeah. Go ahead. You guys have the right name tags, everyone? Okay, yeah. Hmm. Algorithms and train the computer to learn the patterns from the historical data or the data that we have available. Okay. Any other point of views?
Yeah.
Okay.
Yeah. Why data? Say the solution actually completely.
Fair enough.
Yeah.
So I think those are all good views. So let me see if I have something on my blog where you guys can quickly take a look to familiarize yourself, and then we can kick off the discussion. We'll begin with the data cleaning module, right, which is the outliers, missing values, and then we will just simply apply them for some of the other things. Okay, never mind. I don't have anything handy right now. So what I'm going to do instead is let me see if I can just do a quick Google and can find out. If not, then I'll walk you through my notebook directly. Okay, never mind. So let's look at my notebook only, the one that I have on my screen. And what I can do is I can share this notebook on Teams, right? And you guys can go ahead and familiarize yourself with this. And then I will try to run it from my system. So I'm going to download this and share on Teams. So you can also have this as a point of reference. And I'll share the PPT as well down the road. So you guys will have some documentation of what we are talking about over here, right? Teams you don't have. So I'll share with Abhi on email, and Abhi will share in the right forum, yeah? That's right. So I'm going the notebook I'm sharing, Abhi, if you can share with everybody else, so they will have it, and I'll wait for you guys to confirm that you have. Okay, so I've shared two notebooks with you all, and I'll wait for you to confirm whether everybody has it. You can try to run it, and then we will start the discussion on it, right? So in interest of time, Abhi, I'm sharing some other links on the chat. So you can, whichever forum you have agreed on, you can share there. Yeah. I'm just gonna send you some documents. Okay, so I've got the link, people, the link that I was looking for. So what I can do is I can give you some time to quickly read this, just at a very, very high level, this article that I've shared just now, which is Machine Learning and Data Science Intro and FAQs, right? And let me see if I can find the article number as well from my blog. So I'll give you maybe 10 minutes to quickly take a look at this. It is 27, but somehow it doesn't pull up, right? So yeah, so we'll begin here only on this article, and then we'll talk about the supervised, unsupervised, all the other things. So this is a very, very dated article. By now it's like 6 years old, but some of the things don't change over a period of time. So this is still very, very relevant for what we're looking at. Yes. Yes.
Yes. Indian based, not in starting. So just to confirm, you will be saying which forum we have become. I'm sharing the channel. The weeks and the language we will go to the okay. Thank you. Can you create one channel for we are active that channel, but we are not using not getting now people are reaching WhatsApp and it's getting disturbed. This is one.
Hi. Come. Okay, shall we start? People have read? Or more time? Done. So you want to start? What's your name again? Huh? Deepika. You don't have your name tag. Or is it hidden? Yeah, there you go. Yeah, go ahead, Deepika. You want to read more? Okay, then you take your time. Santosh, you have read or not yet? Okay, so we'll wait for 5 more minutes. Yeah. Abhi, which forum have you shared the link? Teams. And I think you can maintain a running like a list of all the links that you're looking at because I'll be sharing it. Able to keep this properly. Yeah, yeah.
पवन में ऐड कर दिया उसने टीम्स को मेडिकेट कर टीम्स दोनों को आप देखो ऐड कर दिया
Sorry. You want to start?
Yeah.
You want to come over here?
Sure.
Come.
Can I use your screen?
Yeah.
All right. So,
Remove the distracting so that people can see it better.
thanks. Yeah. Yeah. So we have three things here. One is AI, machine learning, deep learning. Are they same things? Actually, before I started this course, I was also confused. Still, I'm confused, but I have some. Yeah, but still, I am confused, but I have some pointers to just separate them.
If you're confused, that means learning. If you're not confused, that means there's nothing new to learn.
Yeah, it is very hard to actually, because if you're a programmer from C++ and Java,
Yes.
it is very difficult because this is totally based on the data. And I mean, it was very difficult for me at least.
Yeah.
So it is like the diagram shows, right? One is we have a superset then. So basically the AI, whatever AI we are saying actually is a kind of algorithm. It is not a new thing basically. We have so many systems where we have the things happening, but right now because we are using in the real situation where humans are mainly interacting, right? So that's what we give the algorithm. Whatever we do, we cannot do every day. For example, I want to send a mail, or let's say the HR department want to send a mail to all the candidates who are selected. They were doing manually earlier. They can write a small routine or whatever it does for them. So basically, we are actually trying to delegate our work to the machine.
Yes.
Yeah, so that is, I mean, AI. Again, like it has a lot of definition from the books and people say. Same thing here. I think AI is like say superset, right? So machine learning is part of that. When we have a machine which is ability to improve its performance over a period of time, right? So we give some better algorithm or maybe the better way of handling the things. Okay, that's machine learning. And if you go further deep, you have a supervised learning. This is very interesting, actually. I was reading this one long back, and so supervise is definitely you are giving a supervision. So somebody is trying to tell you that this is that. So one of the example I was reading is that mother comes in front of kid every day, and mother says she's in, let's say, one black suit or salwar kameez, and she says, "I'm your mother." Okay. So the kid actually it flashes on the kid mind that okay, she's my mother. Next again, same thing happens. So basically, you label the data. For example, this is cat, tag it. This is dog, tag it. And different images you are going to give, right? So it's like you are giving supervision. For example, we have done some exercise. When I was doing it, I was not sure, but then I came to like spam and ham mails, right? So those kind of things. So it's quite interesting. I will not take much time with that. Yeah. So this was one of that one. Deep learning, I'm not very sure, sir. What is this? How to explain? But then again, I'll go to there is unsupervised this one also, right? So that is we don't give any information. When the data is given to the machine, it will take to a category or a place in the memory area or whatever the graph, and it'll keep it here. So I'm not saying that this is an image of a cat, but it goes and sits in the area where cat and dogs they are belong, right? So that is unsupervised learning. Yeah, uh, that's it.
Anything else, Paul?
Yeah.
Or you're still reading the rest of it?
The rest of the things, yeah, I was reading. This section, I think it is quite, you have, the link has all the information, like we do what has happened, right? What is, why it is happened. That is, I mean, this is one of the, you can say when we have the requirements or design in the software phase, these questions we have to ask ourselves. So it is similar to that, I believe. What should happen in the future? Then what is the plan? How should we do it? So, for example, in this one, point number 3, we train the algorithm. 80% data we give, okay? Then 20% we keep it for testing, and then we give the actual data and ask. For example, I have a program where I have a PDF file, and it has a requirement for the software engineers, where I'm saying Python is required. Now, if the guy has the Python as a keyword, and I'll just give it to the algorithm, and then I'll say find this guy suitable for this position or not, because Python is already mapped inside that memory or whatever. I say memory because it is actually real memory of the machine. So, and I don't use computer because most of the time people call it computer. I don't like it because it's a machine. So I use machine and the memory, because that is the way I think whenever I write a program. Yeah. So I mean, people can add something to it. That's it, sir.
Great. Anybody else? Thank you.
Yeah. Thanks.
For beginning the journey and explaining things. Anybody else wants to come in? Come. What's your name? Pavan. Come. You need to plug in your system. Okay. Hey.
So AI versus ML. ML is machine learning via data. So we have data and we want machine to learn from that data. And AI is mimicking intelligence. Either it is human or any living being. You want to mimic that intelligence. So to AI to function properly, you need machine learning algorithms first to make that machine learn and then mimic that AI. And to have the machine learning algorithm, we have two ways: supervised learning and unsupervised learning. In supervised learning, we basically solve classification problems, whether it is an apple or an orange. So it can identify whether, again, from the same data set, you'll give your 80% of testing, 20% of testing, and 80% of the training. And you'll make that model or that machine learn from that data, and it will do the classification for you. And lastly, there's one more: regression. I'm not aware of that, how that functions, but
Anybody knows what is the regression? Supervised or unsupervised? Go ahead.
join.
You can also join.
So regression analysis is a method or measurement using which we can see what is the average relationship between two variables. So for example, I have two variables X and Y, and I want to know, is there any relationship between them or not? So if X increases, Y will increase or Y will decrease, how they are related. So based on X, I can predict or I can measure Y, or based on Y, I can measure X also. That is the main thing of regression analysis. And there are many rules also in regression analysis. If we do regression, there is a common assumption that both whatever variables we are having, they should have a linear relationship. So if one increases, linear relationship means if we plot the data points, it will show as a linear graph. It should not be non-linear. So we can, it should be form of y equal to mx plus c, or in machine learning or statistical term, it should be h theta of x equals to theta 0 plus theta 1 of x. Theta 1 of x, if we are having one single feature, or x. If we are having multiple feature means whatever data we are having apart from the target. Means if we are predicting y based on certain features, so that will be our x. So if we are having multiple features, x1, x2, x3, x4, for example, if I want to predict student can pass or not based on study hours, internal marks, and sleeping hours, all these things. So student will pass or fail, that will be our target variable called y, and all these three will be our features called x. X1, X2, X3.
We talk about the regression in more details later on. Anything at a high level later on.
Yeah, so regression is mainly, another thing is assumption is, for regression, target, whatever we are predicting, that should be a continuous variable. It should not like discrete kind of things, or it should not be any categorical like 0, 1 or 0, 1, 2 kind of thing. It should be continuous. And another thing for regression that is also very important is whenever we do any kind of regression analysis, in while doing regression analysis, we draw one line that is called regression line in statistical term, and in machine learning term, we can say this is a best fit line. And based on the best fit line, we can calculate the errors between the actual data and the predicted data. If we plot the errors, there should not be any pattern kind of things. Like if we change the data, errors.
Details. Yes. Again, revising machine learning algorithm, two categories, supervised and unsupervised. In supervised, you have labeled data. That is how you supervise your model to get trained. And there are two categories, again, classification and regression. Under classification, we tell whether it is an apple or an orange. We train that model. Under regression, we try to forecast the data. We have a parameter, we have a variable, and then we try to forecast on it. Under unsupervised learning, the data is unlabeled. I don't know what this mean, like this column, what exactly it is. Then here we solve the problem of clustering. So by clustering, it means, let's say you want to do ad targeting. So under a specific age group, what type of ad you want to target? So either it is Pepsi or your term insurance. So obviously, so again, there is one more association where Amazon does the product recommendation along with your TV. Do you want to buy the stand? Do you want to buy refrigerator? This sort of problem. And yes, I think this is it.
Awesome. I know, you guys are still learning this, so I don't want to necessarily confuse others by hearing different terms in different lingo. So I'm gonna take my veto power and explain from my point of view, and then hopefully that will make more sense, right? So let's begin with the AI. What does the AI mean to you, Ajit? Yep. Okay. So AI is artificial intelligence, right? Artificial intel. Why is it called the artificial?
Made by human.
It's not natural because
That's a
simulation
Hmm?
is a simulation which matches our brain.
Right.
Based on that, from the past or legacy data, the machine, we have to train the machine such a way that it
Yeah.
should understand like a human.
Exactly. So you're training the machine basis human intelligence, right? So you're transferring the human intel to the machine and you're artificially making them intelligent. That's why it's called the artificial intelligence, right? Any examples of AI that you see in your day-to-day life? Hmm. Sure. Okay.
Currently, it is fully ML paper.
Mm-hmm.
So whatever data we have given, there is no rule-based coding. So how the model trained based on user input or question,
Mm-hmm.
it will learn the pattern of the question, and based on that, it will go to based on its knowledge, it will give the answer.
Yep. Okay, great. So I think the another definition of the AI is what we call as the augmented intelligence, which is not the human intelligence or not the artificial intelligence alone, but most of the productive work will be augmented intelligence, where you are working very closely with AI to make better decisions, gain productivity, make things faster, make things more effective in general, right? So this is where the word is moving, which is the augmented intelligence, right? So if somebody tells you that AI is gonna take away your job, it will. But then if you are working with the AI, then it won't, right? So then you're actually working with the AI to really have that augmented intelligence, right? And AI, I think, as Santosh, you pointed out, is not a new thing. has been there for many, many decades now, but it has recently gained a lot of traction, and pretty much everybody is using them in some shape and form, right? So in interest of time, I'll move on. I mean, all these numbers are very, very small by now. I mean, things have moved a lot, right? This picture is very important. I think you need to have a very good understanding of it because it will always come back to you in any of the work that you're going to do, right? Which is the broader set of universe, anything which machine can really replicate the human behavior or try to do things which human would like to do is called the artificial intelligence, right? The first part of the artificial intelligence, or the bigger umbrella term, is machine learning, right? So machine learning is when you're giving the machine historical examples of the data and trying to train it to learn that behavior, and then machines learn that behavior, and then they can help you make the prediction, help you do the regression, help you do the classification, pattern recognition. All of those things are machine learning, right? Deep learning is a subset of machine learning, right? So you can see this is entirely part of the machine learning. And what is a deep learning? Deep learning basically is following a particular type of technique called the neural networks, right? Which you'll be learning in your deep learning classes. Neural network is nothing like a human brain would work, right? So how does a human brain work? I mean, I don't have a supervised learning algorithm in my brain. I don't have a unsupervised learning algorithm, right? We just do things. We have the reflexes, we have this memory, we have like the reward system, we have many, many different things where there is a action, we will do a reaction, or there is a greed, or there is a desire. All of those things are something which your brain is controlling, and your brain is saying, lift your hand now or drop the hand now, right? I mean, I don't know, I mean, whether I've written an algorithm to do all of those things. So that's the neural network, right? So you have an objective function and everything is being controlled by neurons, right? Which is a very, very sophisticated technique. And this is where all the LLMs have been trained using deep learning, right? And I will talk about that a little bit later on. And then there is a lot of people are not using this term right now, but this is being replaced by AI and ML, right? So AI and ML is a broader umbrella term which cuts across pretty much everything that you're doing over here, right? Why AI and ML? Because AI is the mother of all things that we're learning. And ML is, you can see, a bigger subset of the things. So people are using AI ML. So for example, this is a standard lingo that we would be using in AWS, in Amazon, right? So the teams are AI ML team, right? People call them data science team, AI team, or analytics, and all of those things. So, but they're roughly the same thing, right? So any questions so far? Any thoughts from anyone?
Sir, a quick question
Uh,
from my side.
just a second, folks, online. I mean, there's a question in the class. I'll come to you in a minute. Yeah. Hmm. 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 Okay. So chatbot could be any of those things, right? So I could have built a chatbot using a deep learning. I could have built a chatbot using a generative AI, right? Which I haven't spoken about yet, right? Or I could have a chatbot built that Arpan was talking about, a rule-based, like a decision tree, right? Are you talking about X, Y, or Z, right? And if you say X, this is nothing but a Python script. Then you again give ABC, three options or four options, right? I mean, that could be anything. Chatbot could be anything, right? And that's the beauty about any of the work that we do in our day-to-day life. It could be machine learning, it could be deep learning, it could be generative AI, right? But all of them are AI. So that's why, I mean, AI is a safer term to use. So you can say, I have an AI app or I have an AI solution. You really cannot say that I have a machine learning solution unless you're really doing a machine learning. You shouldn't say that I have a deep learning solution unless that is a deep learning solution, right? So those are very, very narrow terms. AI is a broader term. You're safer to use AI as a term, right? That's why you can see AI will do this, AI will do that, or I have AI driven app. So because AI catches pretty much everything. I hope that makes sense. Rule-based are not AI systems, but I mean, right. That is not AI, right? So when you're trying to give that behavior to the machine to learn from your, like how a human would do, right? So, I mean, I think up to a certain extent, you can also say like automation is AI, But then you're getting in the territory of the gray area, right? Which is like, I mean, it's not necessarily an AI in true sense. That is more rule-based automation. AI is when there is some decisions happening on the fly, some decisions which could be like non-deterministic, right? Some decisions which are going to be having a certain probability associated with them. So those are AI. If I know if A happens, then B will happen, that's not necessarily in true sense an AI. But I mean, definition is a little bit hazy there. So you can still use AI, but you need to justify why this is an AI, right? Any other questions, thoughts from anyone? All good? Okay, so then moving on. So, huh? Sorry, online there was a question. Sorry, good thing you reminded me. Yeah, somebody had a question online.
Yes, sir. It was partially answered by your previous query. So I was
Uh-huh.
talking about, I was thinking about Gen AI. Where should we put it in that,
Yes,
in this Venn diagram kind of thing that you have? I think it's a subset of the artificial intelligence then,
that's right.
if I'm
So the
okay.
training of the Gen AI is deep learning. Most of the Gen AI algorithms are deep learning. And when we talk about the supervised and unsupervised, we'll talk about this. But then the Gen AI is over here, you can imagine.
Okay.
So all the like the generative, and gen is nothing but the generative, right? Which is you're generating. What are we generating? We are generating text. We are generating images. We are generating videos, right? We are generating voice. We are generating any number of different things that we typically can understand as a human, right? So basically, all of these are nothing but your NLP or NLG, right? Natural language generation and images and multimodal concepts, which are basically something that we can understand, right? So that's the beauty about the generative AI. So I'll come to it in a minute, but that's part of this. Is this diagram clear? Because if somebody asks you, since you are in the, you have done a master's in AI and ML, please explain all these terms to me, right?
It's a data of AI,
Hmm.
but in terms of statistics, analytics will be doing descriptive statistics, right? It is not like inferential things.
Yes, I'll come to it. So this also includes business intelligence. This includes your, what do we call that? I mean, there are many, many different terms people use in industry, right? So, but analytics was when I started my career in this field. So it was a very, very popular term, analytics, right? Which includes your business intelligence as well. And business intelligence is nothing but the reporting and dashboarding to a large extent, right? Very, very lucrative field. And not everybody in this class may be working in the generative AI or predictive AI. You may still find a very good career in the business intelligence, right? So softwares like Tableau, for example, right? Or Power BI, right? Or the visualization in the Excel is all part of the BI, business intelligence, right? Okay. Hmm. Artificial intelligence, like I said, is a superset, right? It includes. AI doesn't have to predict though. AI can do the automation also for you, right? Or AI can answer the questions for you also, right? It doesn't have to predict all the time. So prediction is a very, very small, narrow subset of the AI. AI is like the sky, it's all over you. Everything is AI. Within the AI umbrella, then you are looking at when I'm doing the prediction, it could be either machine learning or a deep learning. But not all predictions using machine learning and deep learning will, all of them will be AI, but not all AI will be machine learning or deep learning, right?
When it initially started, like in the making of cars,
Hmm.
or the robots and things.
Hmm.
So I thought that is those all are machines.
Hmm.
So that is machine learning.
Hmm.
And that is different from deep learning. It is like that, or
Yeah, I mean, I can understand your confusion. Machine learning does not necessarily involve a machine, but everything to that extent is a machine. Your computer is a machine, right? So to your definition, right? So yeah, so your computer is a machine. So if you're teaching your computer to do certain thing, you are training a machine. Your Excel algorithm is a machine. right? Because it is doing, some formula and all of those things, right? So machine learning doesn't necessarily require a big robotic solution per se, is what you should be clear in your mind, right? That's a different branch of the AI, which is the robotics, right? Where you are having a self-driving car or robot or things of that nature, like, vacuum cleaners, for example. A lot of those robotics are coming in. There was some other question. Yeah. Okay, that's a good question. Anybody who can give me an example, something which is a machine learning and AI, because all the machine learning will be AI, and something which is AI but not machine learning.
If I am building a
Hmm.
chat
Hmm.
machinery where I want to predict sales data based on certain features.
Hmm.
So I am having one CSV file. So I for that I use a machine learning algorithm called linear regression. I created the model and I am predicting the based on the data, based on the features, I am predicting the sales data. So here I am calling it as a machine learning because we are having data, historical data,
Mhm.
which and I am predicting our target.
Mhm.
So both are I am applying statistics here.
Yes.
One is called descriptive statistics, where I am analyzing all this data, and I am using inferential statistics also, where I am predicting the target. So I
Mhm.
can call it that machine learning things what I am developing now.
Okay.
Now that I converted it in a pickle file, and that pickle model I have created on chatbot. I use that model inside the chatbot. So my chatbot can answer if I give the new features, it will predict the sales data, and based on its prediction, it will give me the sales data. So that is the specific tool that chatbot developed by purely machine learning algorithms. And same way, whatever we are having LLMs, where we are not training our model using historical data, we are not predicting here anything. So I created one chatbot using Llama model or any Gemini model. I have given some data. I used some documents for RAG-based application kind of, for example. And there also, if I give any questions based on the documents, it will give the answer. But it is not machine learning because it is not predicting my answers based on historical data. So instead, it will find the pattern of user input. It will go to the database and it finds the answer. It will give me the answer. So
Yep.
this is the AI things.
Great. Good example. So I'm also, while you were explaining that, Pranav, I'm like, talking about some of the other things as well. So like, if you have built a model, used car price prediction, right? So when you go to Cars 24 or Spinny or any of those apps, right? So they will collect all the data from you, or I mean, they will actually inspect your vehicle and they will have a form that they're internally filling out, and they will say what is the age of the car, how's the condition, good, bad, excellent, the tire quality, the battery, all of those things, right? So they basically get all these inputs, and those inputs are fed into a model, and within some time you will get the car prediction, right? So that's basically nothing but a supervised learning algorithm, most likely, and it's a machine learning algorithm. There is no generative AI, but because machine learning is a subset of AI, you will still call that an AI, right? Is that clear? Which is a typical machine learning, and that could also be a deep learning algorithm. So the same thing, depending on the technique, I could be in the territory of the deep learning also, right? But right now I'm saying because I have used a simple regression model, that is a machine learning algorithm, right? Now come over to this side, which is in the AI, and particularly within AI, a small section, I mean, it's growing big right now, is Gen AI, which is I'm providing an image to like a Nano Banana or Stable Diffusion or DALL-E or anything like that model out there that generate an image of a dog on a beach drinking Coca-Cola, for example, right? So you're not going and giving a supervised learning algorithm. All you have done is on the fly, you have given the prompt or the caption of the image, and using that image, that caption, it is generating that image. That is an AI solution, and particularly a Gen AI solution, because you're generating something, right? Now, not all AI solutions need to be the Gen AI, right? So, for example, your robotics will be over here somewhere, because I'm not generating anything. I'm taking the action, right? I have the self-driving car, for example. That's an AI. But is it a machine learning? Is it a deep learning? Is it Gen AI? Is it something else? Maybe it's all of them, but it is AI. I really cannot bucketize that as a machine learning solution only, right? Maybe there are certain components which are using the supervised learning. Maybe there are certain solutions which are using the unsupervised learning, reinforcement learning, all of those things, right? So it's a combination of all of them. Right. That's right. So all of those are like, they're not necessarily in true sense machine learning algorithm. They could be, other algorithm or combination of the machine learning as well, right? Okay. Yeah. Voice detection, yeah. Face detection, yeah. Face detection may or may not be machine learning, but if it is a deep learning, then again, remember, this is a part of the machine learning as well, right? So computer vision can also, will be depending on how you've done the modeling. If it is a deep learning, it is a deep learning, but then deep learning is a subset of the machine learning, so you can call it a machine learning algorithm.
Similarly, voice assistant cities also. Voice assistant city.
That's right. That's right. Yeah. They are part of the, they can be part of your machine learning, deep learning, but they are all AI solutions. So anytime you have doubt in your mind, shall I call it a machine learning or deep learning or AI or something like, always go with AI. Cannot go wrong with the AI. It's very simple. You will never be wrong if you say, I have built an AI solution. That's what I'm saying. If it is like, following your directions, you have typified, or like, you have given your human intelligence by the rules also, it is technically an AI solution. But not in the true sense of like, that I've used historical data and all of that. All I've done is built rules. But for building the rules also, you must have certain knowledge to build those rules, right?
Basically,
Uh-huh.
role-based in normally work.
Right.
Set of activities.
Quality AI. Even if you're doing the automation, quality AI. So deep learning, I will talk about that. So like, there are different algorithms in the deep learning, right? So let's say, we are looking at the linear regression, logistic regression. We'll be doing all of them in this module. They're subset of ML. They're subset of ML only. But then we are looking at advanced techniques. So let's say recurrent neural network, right? Or convolution neural network, right? All of those things which are part of the machine learning, but because they're using a special technique called the neural networks, they are deep learning algorithms. So all deep learning are machine learning. All machine learning are not deep learning. Deep learning is when you use a technique called neural networks. So it's a separate module, and the neural network is one type of modeling techniques, right? So where, and you'll become more clear as you go on in your journey. So these questions are quite like, natural at this point of time. So it's a very different technique altogether, where you have the input and you have the output. You don't have a particular equation like a linear regression equation, that y is equal to beta naught plus beta 1 x1 plus beta 2 x2. I cannot really write the equation. Like a human brain, if you touch a hot surface, immediately your hand comes up, will go away from that hot surface, right? Can I write the equation? What equation my mind really followed to do this example? No. I just know there are like, logics in the neurons. Neurons fire up and they tell you it's bad for you. Back up your hand or take your hand away from that surface, right? That's the neural network. I don't know. I really cannot say, this is how it's working. It's a black box. But I know if there is certain input, certain output will be generated. If you say bad things to me, I will say bad things to you, right? If all of those things are something that the neurons are, our brain is trained like this. How many years our brain has been trained? I think this is a trick question. Arpan will not answer, but everybody else can answer. How many years your brain has been trained? Your age? That's wrong. Since the beginning of the human race, your brain is learning, right? So it like from your parents, from your grandparents, that's how the evolution is, right? So like thousands of years, your brain has been trained. So when you're born, it's not like the training is beginning there. It is already trained. And then you're doing, top up on that, right? So based on your experiences, you're doing a supervised learning, unsupervised learning, reinforcement learning, all of those things are going in. And that's where, you come in with like a huge knowledge the moment you're born, right? All the things that your body knows already has been the evolution cycle itself from the very beginning, right? So that's the same thing we're trying to do now with the machine, that I'm giving you this humongous data, all the text, all the images, all the videos which exist, all created by human only. So no image was created by the machine directly. So now the machines are creating, but originally the cat or the dog or all of those things, we took the pictures and we say, okay, this is a cat, this is a dog, right? Machines did not get born with that information that I know the cat and the dog and all of that. We've trained, and that's where basically the AI really comes in, right? Is that clear? I think somebody has, yeah. Right. Hmm. Hmm.
I say every one of us is sitting on a furniture, that is true. But to be more specific, we are sitting on a chair. That is same with AI and ML or any deep learning.
Yep.
If I say this model is working on AI, that is true.
That's right. That's right.
Which is correct.
Yep.
Furniture.
That's right. That's right.
I have to say we are sitting on a chair.
Mhm.
More specific.
That's right. That's right.
the knowledge we will-
So you'll become more specific when people know what you're talking about, right? So if they don't know, use the term AI. Don't use deep learning, generative AI, machine learning, or supervised, unsupervised, reinforcement, semi-reinforcement, or semi-supervised. They will get confused. If you use term AI, you're all good, right? If they're knowledgeable, they say, okay, I understand it, this is AI, but what exactly you're doing in the AI? Then you'll say, okay, I'm doing a deep learning algorithm, or I have a Gen AI engine, or I have a machine learning algorithm, which connects to a deep learning algorithm, which does this. Then I have a time series forecasting, all of those things. You go in once they show the interest. But when you're having the high level discussion, safer term is just use AI and you're good, right? Yeah, please.
Deep learning for machine, there is no linear algorithm.
Hmm?
But
This, huh?
but math trained it is participated.
Math, there is definitely a math. I mean, you're doing the training of that thing, but the training is like, happening based on the trial and error, right? Or based on a certain way of learning things, optimization and stuff like that. Exactly. Yeah. We'll discuss that. Okay, so moving on. So I think AI, we are clear, machine learning, we are clear. I will explain the supervised and unsupervised, but you can imagine supervised is that you give certain input and you give certain output, and you're training the model to learn the behavior between your input and output is a supervised, right? Supervised meaning that I'm giving you the supervision for you to enhance your learning, right? So in this case, some examples, I have given the voice recording as the input, and I have given the transcript as the output. My model will now be able to do the speech recognition, right? Because I've given it like, hundreds and thousands or even millions of observations of voice recording. And then I've also transcribed those voice into the transcripts. Model has learned that if I'm talking this way, this is how it should be transcribed. And that's the speech recognition. Similarly, if you have the historical market data, and then I've also told what exactly will be happening in the next stock price, then I have a trading bots, right? A lot of bots are now built, and AI is like very big in the trading, right? There are companies which are paying 3 crores, 5 crores to freshers from IITs for trading optimization. Huh? Mostly from the tier one colleges. So they are hiring, fresh talent who can help do better job in the trading, right? Using AI. So, yeah, that's right. All of those things, right? Similarly, you have photographs. You can create the images. I mean, you can create the captions, and then we have the image tagging and all of those things, right? So we'll go through some examples. So deep learning, like I said, this is basically neuron, a representation of the neuron. And I will not go in the details, but you can see there are certain inputs There are certain weights it will be allocating to those inputs, and there's some math happening over here, some activation function, some like thresholds and all those things. So message is being propagated, and then there's a backward propagation, and there are many other different techniques that we'll be looking at later on. This is an important slide. When you can do something simple, do not overcomplicate things just for the showing up your knowledge or showing off your like knowledge of the AI and the deep learning and all of that. So if something can be done in Excel, do it in Excel. If something needs a machine learning solution, do it in the machine learning, right? If something really requires a deep learning, then you go for the deep learning and then go as the need be. But simple is beautiful. People do not like complexity. And even if you bring in the complexity, something will break down more often than you understand, right? So if simple works, go for the simple, right? So that's what this really comes in, which is from Andrew Ng, right? He's like the very well-known name in the AI. So you can think about the where you should be using the deep learning and other things versus the normal machine learning algorithm, right? Most of the learning algorithms are gonna perform better when you have, let's say, on the left side of this, you have less data. On this side, you have more data, right? So the deep learning algorithms really like more and more data. So as you give more information, like hundreds and thousands of web pages and like, millions of images and all of those things, you should go with a deep learning algorithm. When you have less data, let's say only 50 observations, you should think more like a typical ML algorithm that will give you a better bang for the buck or the ROI, right? Or even a better performance of the model as well, right? So there is a trade-off. As the amount of data grows, machine learning models hit a plateau. They will not be learning. They'll say, okay, this is it. That's my limit. I really cannot learn more. But as the amount of data grows, the deep learning algorithms say, bigger is better for me. I will keep on giving more and more performance for you, right? So that's why a lot of people are saying the LLMs have hit their limit. Why they have hit the limit? Like, I mean, you really cannot build a better LLM right now. I mean, that's what some people are saying. Why? Hmm? Hmm? Say it one more time. Because they have already seen all the data. There's nothing left for them to see, right? All the images, all the videos, everything you can imagine has been thrown to the LLMs. Everything out there in the world, LLMs know, right? That's why they are able to do the like the medical, they are able to do the electronics, they are able to do the mathematics, they are doing PhD level problem solving, they are doing a lot of innovation in images, videos, and everything because they've seen everything. So it's a function of data. You have to find the data from somewhere. If I've already exposed all my data, there's nothing new for the LLMs to learn, right? So what people are doing now, anybody knows? They're doing synthetic data. This is going to be a very upcoming field where, I mean, we are saying, create new data. I don't have to necessarily wait for the data to be generated. I will create my own synthetic data, right? Any examples of synthetic data, people, from anyone? Yeah. Yep. So you're doing the simulation, you're creating that data. Take a simple example. Let's say you are building an engine for cyber security, right? You want to build your own AI for cyber security, right? You really cannot wait for the events to be happening to really know how your system is going to perform, right? So you'll say, okay, I will pretend then there is a breach. I will pretend that there's some sort of bad input coming in, adversarial input coming in, right? So you'll mimic those situations and using, you can again use AI. So you begin with AI, you end at the AI. That's how the word is right now. So you'll use AI to create the synthetic data to feed into the AI, but it's a different AI system to do some AI work for you. So just keep on throwing AI in everything you do in your life, right? And you'll be solid. Any other doubts on this one? Synthetic data is more like you're generating the data. So for example, let's say I want to look into the credit card fraud or default prediction, right? And I want to now create the data. So let's say most of you, how many of you do the investment in the stock market or mutual funds? Mutual funds, okay, few of you, right? But you haven't seen what a 2008 may look like. I think most of you have done after that, right? So you haven't seen how the bad really looks. How when people are jumping off the bridges because they've lost 3/4 of their money, how will that situation look like, right? So a lot of new investors have never seen that sort of bad, blood on the market, right, on the road, and how they're gonna behave in that situation, right? I mean, so let's say you invested, I'm just making up a number, like 50 lakh rupees of your hard-earned money in the stock market. You wake up, the market is down 10%. It's okay, ठीक है, कल आ जाएगी वापस, right? You wake up, it's down 20%. You wake up third day, it's down 30%. And now you're panicking. Now you're not able to sleep. What is going to happen to my money now, right? That's where the synthetic data will come in, which is, generate a very, very harsh bear market where the market is going down 30%, 40%. What is going to happen to my portfolio, right? How downward protected my portfolio is, simulate that behavior. And using that simulation, using that synthetic data, then you say, okay, do I have, too much of the stock or equity? Shall I move some money to gold, which is like, good hedge, right? Shall I move some money to debt instrument, right? So all of those are being done by generating that synthetic data, right? So the Nifty is down 10%, right? These IT stocks are down 15%. So you're generating those data to really do that behavior. Similarly, I mean, for training our model also, let's say, I mean, right now, a lot of LLMs are being trained using the synthetic data, right? So for example, let's say I am working for a particular client and that client is in a fintech industry. I will give some data to it, right? I mean, I have seen this sort of default behavior in the past, right? People who have CIBIL between 680 to 720 has this default rate. People between 720 to 750 has this default rate. People who have more than 750 CIBIL score is this default rate, right? Create more data on those lines. So it will say, okay, fine, I understand, what is the pattern between this and this. Using this, it will create more data in the same areas. And now you say, okay, now I'm actually trying to, because I need to acquire more customers. So I'm dropping my threshold of the CIBIL from 750 to 680. Now you have this artificial data, synthetic data that is generated. So it's okay, now go and model for what my default rate will look like, right? And now because I have that default rate prediction, then I can say how I should price my loan. How should my interest rate behave to really safeguard my interest, because it's a risk reward trade-off that you're doing. So if I'm taking high risk, how much extra I need to be earning from the customers to justify that high risk. So that's where the synthetic data really comes in. Gutter says 40%, 50% of the work in AI will be happening using the synthetic data because we have run the limit. We really cannot generate the a lot of new data, because right now what is happening with the images and the videos? Anybody knows? They're all generated by AI only. So very few people are generating new images. Like, I mean, even Deepavali also people are just creating a diya and all of those things. And I mean, nobody's taking the risk to go and take the real picture of a diya and put it out there, right? So they're saying, okay, happy Diwali and this and that, and all AI generated images. So if the system itself is generating, you're already looking at the synthetic data, right? Yeah. Why ML or why us? Why ML? ML will see, I mean, when you, right. That's right. That's right. That's right. So when you're trying to, let's say, when you want to tighten the screw in this glasses, right? You need a very small tool for doing that, right? You really cannot have the drilling machine. Let me go and fix it. LLMs are like a drilling machine, right? They're like really huge. They have really good capabilities, right? So they're not suitable for every single thing. So when you can keep it simple, and LLMs are very cost intensive as well, and they are bad for the resources. the carbon footprint is really bad as well, right? So people are trying to lower down the cost, not just for the training of the LLM, but also doing the inferences when you're running a query. So OpenAI came out and say, if you don't use please in your query, you can save so much money. They will save so much money. So please send me this, right? Just cut down the please and all the formalities. LLM is not a person, but we treat AI as a person, right? So we're telling all our inside stories, ki boss, I'm really unhappy, or my boss said this to me, what do I do and all that. It's not a person, right? Uh, please suggest, please do this. So all of those please are adding up to like your significant cost in and we are creating a lot of bad things for the earth overall. So not necessarily required. Only when you have to do the heavy lifting, then that's where you deploy the LLMs, right? That's right. That's right. Absolutely. So moving on to something more at home. So what is AI ML, right? So you begin with your data. Data can be structured, unstructured, semi-structured. What is the difference between the structured, unstructured, and all of the different types of data? Right. It might be JSON, it might be text, it might be combination of different formats of the data as well, right? So like images, emojis, videos, audios, all of those are unstructured text, right? So any type of data comes in this AI and ML engine right over here. And this AI and ML engine could be deep learning, machine learning, could be AI, could be anything, could be Excel also, right? And out comes the business insights and business impact, right? That's where you are doing like AI and ML. So there has to be some sort of impact coming out. The way you should define your work in AI is also you need to answer the question of the business impact or answer the question of so what, right? So let's say you are trying to highlight, some of your work and we'll take a break. I think we're almost on time. So you've done some work and you want to highlight a repo in your interview, right? On the Git, for example, you've done some work and you pushed it there. So it must answer the question of so what, right? From the business point of view, from the impact point of view, not from the AI and ML point of view. Like, I have built a model which has a precision of 80%. The next question somebody's going to ask is what? So what? Why do I really jump up and down that you have a precision of 80%? It doesn't mean anything to me as a business leader, right? Huh? What is it that it will translate into? The impact or the business lingo is what most of us as an AI professional, we don't do that often, right? So in order to be a very good AI resource in any company, you have to think like a product leader, think like a business leader, right? And then wear your AI hat, not that you're always walking with your glasses of AI only, talking like a AI only, right? And not thinking like a business person. So ultimately, it has to be translated into why do I really care about anything you've done, right? I mean, I really don't care. You have to tell me why it really matters for me, right? So that's where you have to talk that lingo, which is where the insights and the business impact is something you must articulate, right? So you can say, I have built this model which improves the precision from 70% to 88%, hence translating into the incremental cost saving of $5 million. Now you're successful as an AI professional. If you just say the precision has grown from X to Y, doesn't mean anything, right? I mean, it's a good thing for this community, but people outside this room do not care. They don't even understand what you're talking about. I mean, they'll say, yep, I understand precision, but explain what precision means to me. Nobody will be able to tell you, right? But the moment you say $5 million, from the bottom till the up, everybody will remember that Ashwarya built a solution which created a $5 million impact, right? They will forget what precision is, what number you quoted, and all of those things. Dollar numbers stick in your mind, right? Or efficiency gains, right? You can say, I can remove 10 resources and deploy them in some other place. Hence, the saving is 90%. 90%, I remember, right? So that's what you have to be really remembering, that that's what you should be translating the outside to the outside world, right? Shall we break and then we can come back and then resume from over here? Yeah? Okay, perfect. Thank you. Folks will take a quick 15-minute break. 11:45 will be back, yeah?